So I've been challenged to create a tapered groove in the wall of this cylinder. This is to fit an O-ring and keep it captured within that groove. So it's not just a straight slotted hole. It needed to have a taper so we could press the O-ring through into it and hold it captive. Okay, so we've got a cylinder here. It's got a diameter of 115 millimeters. We've got a bore here that's 67 millimeter diameter, and I need to obviously protect the outside of that with an O-ring, okay, because of where this thing will sit. So first thing I'm going to do is, well, for this feature, I'm going to use the swept cut command. So the swept cut requires a profile sketch and a path sketch. And even though it asks for the profile first, it's always best to create the path and any guide curves before you even think about drawing your profile. So that's what we're going to do. So let's just clear that away. So here we have our parts. What we're going to start with then is a sketch to help me define the shape of my profile path. So I'm going to put a sketch on that front plane here, and I'm going to draw an ellipse. Okay, now it is a circular hole, but I might want to be able to control the overall size of this circle a little more. So I'm going to make it into an ellipse so I can just control its width independently of its height. So I'm going to make the height about 80 mil, and the width here, well, let's try 80, which does make it a circle, but let's go with that. Now the sketch is still underdefined. The reason for that being that I could still move these control vertices of the ellipse. So I'm just going to select two of them there and make them vertical to each other in this instance. Right, so this is almost the path I want it to follow, but it needs to be following that, but scribed on this surface. So although there is a wrap command that's possible to use, for this we can get away with just using the split line command. So this will project that sketch onto this surface. Now I'm going to tick single direction because that way I can choose for it to only affect one side of the cylinder. Okay, now if we do that, we now have a line scribed on the surface. That is going to be the center of the opening of my O-ring groove. Okay, so we need to, we're going to create a sketch that's going to follow this path, but as we sort of look around, it can start sort of horizontal, but then it's not going to stay square because it has to follow and track round the cylinder. Okay, so the only real way to control that is with guide curves. Now, the ideal guide curve for me here would be something that was normal to the surface at that edge. And we've got a command in SOLIDWORKS for that. It's on the surfaces toolbar, okay? And it's this one here called ruled surface. We can select that and we get a whole bunch of options for what we can do in here, okay? Taper it to a vector, perpendicular, it's swept, or we can go normal to surface. So that's what I'm going to do here. The 10 mil distance isn't particularly important, but now what edge am I going to use? I'm going to use this edge here. So let's hit OK. Now, if I look at that from the right, we can see that that is going perfectly straight out from the wall of the cylinder at that point. And if I go and look from the top, we can also see that it's going straight out normal to the wall of the cylinder at that point. And indeed, it's doing it at all points around that edge. So this is going to be my guide. This is like the rails on which my sketch is going to sit for this swept cut. So I'm going to draw the profile for my swept cut. Okay, so we're going to sketch on the right plane, and it's going to be a triangle, this cut, okay, for a simple dovetail. So I'm going to draw some lines in here. Now, purposefully, I am not going to try and make this horizontal or vertical. Okay, I'm just going to draw it out like this at an angle. For reasons that will become clear in a moment. So I'm going to draw a construction line out from here. Okay. And I'm going to draw another one across here. Now, if I hover over that line, it will pick up the perpendicular relation, so that's quite nice. And I'm keeping all these things perpendicular to each other. Okay, that is going to be the control I have on this particular sketch. So I'm going to select those two, make them coincident as well. I'm going to specify my opening width for this hole. Let's say it's about 4.5 mil. The depth of this groove, I'm going to set, well, let's just set it at 4.5 as well. And then an angle for this, I'll have it fairly shallow angle. I don't want it too tight. I'm going to make it 40 degrees. Okay, so we have this sketch in here. Now there's one more thing I'm going to do. I'm going to put a little sketch point on this line, but then I'm going to take that line, hold down the control key so I can select the other one, and I'm going to make them coincident with each other. Okay, so I've got a control vertex here, and I've got one at the end of this line that I just extended out, and I didn't give it any sizes because I didn't need to at this point. Now, I need to attach this onto this edge here. Now, if you do pick a 3D edge, like I've done here, the option you get for a sketch relation is the pierce relation. So it will thread that edge through that point. Okay, so it now knows exactly where that part is. And if we take this one, we can do the same for the outer edge of this surface and pierce those two together, and suddenly my sketch is perfectly aligned. Now it has got, I should say, horizontal and vertical lines to it, but if I'd left them horizontal and vertical, as the sweep progressed around the profile, that horizontalness and verticalness might get defeated in the plan view, because what would be horizontal and vertical wouldn't be in line with my profile, this surface. Okay, so that's one of the reasons why we had to make sure we weren't using any vertical or horizontal sketch relations in this little feature here. Okay, so I now have an edge that I can have for a path. I've got an edge for a guide curve, and I have a profile. So I'm good to go, ready to do my swept cut. Okay, so we have our swept cut here. So the first thing it asks for is the profile. We can then select the path. And so if we hover around here, you can see the tip of this profile, it's not really capturing the edge of that surface. You see, it doesn't quite follow the curvature perfectly. So this is where the guide curve comes in. So if I can go to the guide curve and I select that outer edge, we'll now see that it is squaring up, and that tip of that triangle is following that surface as we sort of move around there. You can hopefully see what's going on. Okay, so we can do that, and we can just cut into the part, and we have our cut. Okay, a little bit of tidying up I quite like to do here. So if we take this surface body, okay, we have got an option to delete it. The direct editing tab will help us here. So we can either delete or keep bodies. So I'm just going to delete that one, just so I'm not distracted by it. So we've just got one solid body in this part. A little final flourish perhaps would be to add in some fillets on this face. Let's make it, say, 1/2 mil fillet in there. Okay, and also on the front edge, I might want to add some fillets on that as well. We can try 1/2 mil. I'm keeping them on as separate features because I can always refine that path later on. And here is my tapered O-ring groove that appears as if it is maintaining this sort of normal relationship, this perpendicular relationship with the outer surface. Now, one way of double checking that would be just to hit the top plane there, do a section view, and you can see the effect of that O-ring groove. Now, depending on the application that we're looking at here, this is the smallest that wall thickness will get. And if we are concerned about that, then perhaps you need to consider our original split line feature that we had. Okay, and so instead of 80 mil, we might decide that perhaps 85 is the size that we want to maintain enough solid geometry in there. It's obviously lengthening the O-ring groove, so you have to make sure it is long enough to fit in there, but that that's what you may need to do. Okay, if the groove becomes so large, it's getting to near the 180 degrees of arc that we're having to try and follow, then we might have to have gone down a slightly different route with the wrap feature, where we can get a sketch and sort of allow it to get wrapped around a surface. But I think for this, we will be okay. So that's it. That's the basic instruction of how to create that tapered O-ring groove, but maintain that sort of perpendicular normal sort of relationship with the outer cylindrical shape. 1, 2, 3, 4 features. It was always going to be more than one, but hopefully not too tricky. Okay, so that was an interesting challenge of the day, was to look at how we could create that tapered O-ring groove. So hopefully you can follow along.